Hi everyone. Welcome to our lecture video on section 1.4, surveys and cardinal numbers. And those are really the two objectives we're going to be looking at in this section. So we're going to learn some applications here of all the ideas that we've seen so far in set theory. And we're going to see how we can use these ideas to organize information and make sense of surveys. And I'm going to show you how to do proper counting with that cardinal number formula. So let's go ahead and turn over to page 2, and I'm going to show you the first idea, and then we'll get into our examples. So problems involving sets of people or other objects sometimes require analyzing known information about certain subsets to obtain cardinal numbers of other subsets. The known information is often obtained by administering a survey. So you might conduct some sort of survey with a group of individuals to find out all sorts of different types of information. When you look at the bottom of page 2, it's going to give us the lead-in to our first example. Now I'm going to tell you right off the bat, we will not try to squeeze all of our work in right here on the bottom of page 2. I left us a nice blank slide on the next page. So right now, let's just kind of read through the scenario, and then we'll turn the page over, we'll lay out our sketch, and that's where we'll do all of our work. So it tells us to suppose that a group of 140 people were questioned about particular sports that they watch regularly, and the following information was produced. So in this case, it tells us that 93 people in that survey like football, 70 like baseball, 40 like hockey. Now, what's important to understand here is these individuals did not have to choose just one of these sports. They were simply answering yes or no questions. So, do you like football? Yes or no. 93 answered yes. Do you like baseball? Yes or no, etc. So, it is quite possible that there are all kinds of individuals who answered yes to all three of these. They could have answered no to all three of these, and so on. So don't think that one individual can only fall into one of these categories. In fact, if you look at the additional information, that's exactly what they're laying out here to the right. 40 individuals said they like football and baseball. 25 said they like baseball and hockey. 28 like football and hockey. 20 people like all three of those sports. Now the questions. How many people like only football? You cannot quickly answer that and say 93. Remember, some of these individuals that like football also like baseball, hockey, or both. Okay, so it's not as simple as just looking at that one number. The second question, how many people don't like any of the sports? In order to make sense of a survey like this, I'm going to go ahead and turn the page where we have some space to do this, and I'm going to draw out a nice large square. Give yourself plenty of space to work here. And what we're going to do here is draw our Venn diagram. Now there's 3 sports in this example, so I'm going to draw a total of 3 overlapping circles. We know there was 140 people total, right? That's the total sample size in that survey. So that's what we want to start with. I'm going to label each of these circles for the individual sports. So I'm going to use F for football. Pardon me. I'm going to use B for baseball, and I'm going to use H for hockey. Now, what I always recommend to folks is to start on the inside of the diagram and work your way out. So if you look back at the given information, sorry it's on a different page, that makes it a little awkward. I actually start with this last bit of information that tells us that 20 individuals like all 3 of these sports. So when we look at our diagram, I know there are 20 individuals right smack dab in the center. 20 people answered yes to all 3 of those sports. Now, I'm going to go up from there. And I'm not going to keep flipping back and forth, okay? I'm just going to read them off as we go. We're told that 28 like football and hockey. So here's football and hockey. They intersect right here. So this intersection needs to contain 28 individuals. We've already got 20 of them, so we need 8 more in this region. Then I move up to the next piece of information. 25 individuals like baseball and hockey. So baseball and hockey intersect right here. Here's their region, their overlap. There's 25 individuals in this region. We've already got 20. We need the other 5. Next, so I'm continuing to just work my way up the given information. They tell us that for football and baseball, there's a total of 40 of those individuals. So I've got 40 individuals in this intersection. 20 are listed here. We need another 20 here. All right, now let's get into the original pieces of information. This time I am going to flip back just real quickly to show you. We've already accounted for all of these intersections, right? All 3 were 20, and then we did the other pieces of the overlaps. Now I'm getting into the original pieces of information where they talk about the individual sports. 40 individuals like hockey. Let's take a look at our diagram. So in this hockey circle, we need a total of 40. If you look carefully, you've already got a total of 33 here listed. 8 and 5 is 13, and 20 makes 33. So here's 33. We need a total of 40. So that's going to leave us with 7 individuals that like hockey only. Next, I'm going to move up to baseball. For the baseball, they tell us that it's a total of 70 individuals. So in this baseball circle, everything has to add up to 70. I've already got a total of 45, so I just need 25 to get that total up to 70. And if you could always use a calculator for the arithmetic, but you just have to make sure that all 4 regions in the baseball circle add up to a total of 70. For football, the total was 93. If you look, in this football circle, you've already got a total of 48. So just take 93 minus the 48. That's going to leave you with 45 of those individuals. Now notice there's one more region that we need to figure out. If we look, you've got 140 individuals total in this survey. We've got the football, baseball, and hockey circles completely done. But don't forget about the folks on the outside. These would be individuals that answered no to all of these sports. So again, they were basically just asked 3 yes or no questions. Do you like football? Do you like baseball? Do you like hockey? They could have answered yes to all 3. They could have answered no to all 3. So let's just add up all of these individual quantities. And again, you could use a calculator if you want, but 40 and 20 and 25, 8, 20, and 5, and 7. If you check that, that's going to add up to a total of 130. You have 140 people total in the survey, leaving us with 10 individuals on the outskirts. Now, all of these regions add up correctly to the grand total. Now that we've got a complete picture, we're ready to answer their questions. There were 2 questions they asked us. First, how many individuals liked football only? That was the only sport they answered yes to. And if you look at the diagram, there's 45 of those individuals, right? 45 people are in the football circle and not in anything else. So that's our solution for part A. For part B, it wanted to know how many people don't like any of these sports. That's, of course, the 10 individuals on the outside. So how many people liked none? There's a total of 10 of those folks. So hopefully that makes sense. It's really, really useful for these survey style problems to organize the information into a Venn diagram. And once you have the complete picture, it makes it so much easier. You could really answer any questions they throw at you at this point. My biggest piece of advice with a problem like this, start in the center and then work your way out from there. Let's move down to the bottom of page 3. I'm going to show you a cardinal number formula that works for any two sets A and B. Now, first thing I'm going to do is write it out as an actual formula, and then I'm going to illustrate this with a Venn diagram. Here's what it tells us. If you want the cardinal number for A union B, so think about it this way. How many elements are in A or B? You simply find the number of elements in A, you add the number of elements in B, and then subtract the number of elements that are in both. So add up all of A, all of B, and then you need to subtract any overlap. And I'll make sure to explain that with our Venn diagram. There's only two sets, so I'm not really going to draw that big square. I'm going to draw instead a rectangle. And I'm going to have two circles here that overlap. And these circles represent A and B. So imagine this is given information here. And I'm just going to start populating these sets with some elements. Okay, and I'm just going to use some letters here. Let's suppose that in set A, we have the letters A, B, C, D, and then E and F. So those are all contained in set A. In set B, E, F also is contained in set B, and I also have elements G and H. So let's see if this formula makes sense now that we can illustrate it with a Venn diagram. So if I want to know how many elements are in the union, now remember the union would be all of this shaded area. I don't want to shade too heavy on this because I want to make sure that I can still see everything. But notice all of that shaded area, that's the union of the two sets. To figure this out, simply take all the elements in set A. There's a total of 6 of them. I then add all the elements in set B. There's a total of 4 of them. And then we subtract any elements that belong to the intersection. Any elements that belong in this center group, the overlap. So in this case, there's 2. 6 plus 4 minus 2 makes 8 total, which makes perfect sense. There's 8 individual letters listed total. The point is this, you can't simply add the two sets together without subtracting the overlap. If you do, you would be counting those center elements twice. And of course, we want those to count, we just don't want to count them twice. Let me go ahead and turn over to page 4, and I'll show you some additional examples. So here they want us to find n of A if n of A union B is 78, n of A intersect B is 21, and n of B itself is 36. Now, there's two approaches you could take to this problem. You could have the formula and you could work through it that way, or you could easily figure this out using a Venn diagram. I'm going to show you both so that you can see what your options are. Option 1, let's do the formula. This works very nicely, very well. It requires that you know the formula. Okay, so that's kind of the downside. If you don't know the formula, this approach is going to be tough. But that formula I just outlined on the previous page says n of A union B equals n of A plus n of B minus n of A intersect B. Now, most of that information is given. We're just going to plug in everything that we know. So n of A union B, that we're told that is 78, equals n of A, we don't know. That's what we're finding. That's kind of like our variable, kind of like x, plus n of B, we're told is 36, and then minus n of A intersect B, which of course here is 21. And now we're just going to solve, just like you would in algebra, solve this little equation. So you can see here, 36 minus 21, so that leaves you with a difference of 15. 78 equals n of A plus 15. To solve it from here, just like in an algebra setting, just subtract that 15 from both sides. So 78 minus 15, that gets you down to 63. That's the size, that's the cardinality of just set A. So that's our correct final answer. Now, like I said, that approach works really well. The downside is you have to know the formula. Okay, so here we're going to lay out the diagram, and we're going to solve the same problem and get the same answer without having to rely on that formula. So let me go ahead and draw a nice large rectangle. And in this rectangle, I'm going to have two overlapping circles, right? These will be for our sets A and B. Now remember, just like I showed you with that survey example, always start in the center. This is A intersect B. And they're telling us we have a total of 21 elements in that intersection. So there's your 21. They also tell us that in set B, total, we've got 36 elements. Well, 21 of them are right here. So we've got the other 15 listed here. We've got one more bit of information, and it tells us that A union B, which is this entire shaded region, has to add up to a total of 78. So if I look here, this entire shaded region has to add up to 78. So simple arithmetic takes 78 minus the 21 minus the 15. That's going to leave you with 42 in this portion, in this region of A. Finally, we can write our final answer, n of A. Just look at set A. And do you see here you have 42 plus the 21. That is 63 total. Notice I get exactly the same answer either way. It's really up to you what option or what method you think is best. The point is you have options. I want to make sure you realize some folks really like this formula because it's very cut and dry, right? Here's the formula, plug in what you're given, solve for what they want. This option with the diagram, I feel like is much more intuitive and you just kind of figure it out as you go. So either way, we're getting the same correct final answer. I'm going to move down to the bottom of page 4 and read through our next example. On a given day, breakfast patrons were categorized according to age and preferred beverage. The results are summarized on the next slide. There will be questions to follow. So we're not going to do everything right here. I'm going to turn the page. I'm going to show you the data, show you the table, and then they'll ask us a couple of questions afterwards. So let's move over to page 5. And this is the table they were referring to. So notice the patrons, the breakfast customers, are organized by age. So we have the young customers, 18 to 25, the middle customers, 26 to 33, and the over or older customers. Anybody over 33 is in this category. What are their preferred beverages? Coffee, juice, or tea? And then out here in the margins, you're just seeing the totals. Notice you have 223 total customers. Now, if you look down at the bottom of page 5, here's where they ask us the actual questions. Using the letters in that table, find the number of people in each of the following sets. First of all, they want the number of individuals that are in the region Y intersect C. Now remember, when you see that intersection symbol, think of the word and. This represents Y and C. So we're looking for the young customers and they like coffee. That's their preferred beverage. So if you look up here at the table, the young customers, and they like coffee, there are 15 of those individuals. So we don't really have to do any work here. I'm going to go ahead and jot down that answer for us. 15 individuals. We basically just have to make sure we know how to read that chart. Now, part B of the example is a little bit more involved. Here they want to know how many people would be in the set O prime union T. So that means not in set O, so not the older customers, or they're in the T category. They prefer tea as their beverage. So what we're going to do is figure these out individually. Let's start here with O prime. That means not set O. Let's go look at our table. Here's set O. Here's the over 33 crowd. We don't want these individuals. We want the complement. So we're talking about the individuals in these top two rows. I'm going to highlight these top two rows. The customers could be young or they could be in the middle. We just don't want those older customers because it's O prime. So if you notice, we've got 55 plus 77. That's going to give us our total for O prime. So 55 plus 77, that's a total of 132. Okay, so we're not done. That's just the total for O prime. Another way you could have done that, if you just take the grand total of 223 minus the 91 older customers, that'll also leave you with 132. So we've got O prime figured out. Next, let's come back down here to the expression. How many individuals are in set T? So how many customers prefer tea as their beverage? So I'm looking at this column, just this T column. That's what I want to highlight. That's what I want to focus on and look at. And notice there are 64 individuals total in that category. So let me go ahead and write that down. Okay, so let's kind of summarize where we're at with things. How many are not older customers? Not O. O prime, 132 of them. How many customers prefer tea? 64 of those folks. Now let's put them together using this union symbol. So remember, and this is what we learned how to do with the previous examples. If I want to know how many individuals are in the union, I add up their totals. So let's take 132 plus the 64, and then minus any of the overlap. Okay? So you just add your two totals together, 132 and 64, and then subtract anywhere that these two categories overlap. Go back to the table. Go back to the picture. Where does this region, these two rows, and this column, the T column, overlap? Notice they overlap twice. They overlap right here. The 18 and 22 belong to both of our highlighted rectangles. So that's the overlap that needs to get subtracted. So let's come back down here to our calculation. 132 plus 64 minus the 18 minus the 22. And when you calculate all of that out, take the 132, add the 64, minus 18, minus 22. That's going to leave us with 156 individuals total. So that's going to be our grand final answer. I really think it's important with a problem like this to do it in smaller bites. Just like this, I figured out O prime, I figured out T, I added those together, and then subtracted any overlap. To me, it's a very visual process. I would never try to figure out this final answer simply by looking and thinking about that expression. That is extremely difficult. So I always look at, the smaller chunks and then how I can combine them. All right, folks, I've got one more example for us to look at. It's going to be laid out on page 6. We've got the given information here at the top, and then there's plenty of space at the bottom for us to do our work. So Scott, who leads a group of software engineers who investigate illegal activities on social networking sites, reported the following information. T is the set of group members following Twitter. F is the set of group members following Facebook. And L is the set of group members following LinkedIn. Now, what we have to understand, some of the group members might be following both Twitter and Facebook. Or maybe they're following Facebook and LinkedIn, or maybe they're following all three, or maybe they're not following any of these social networking sites. Maybe they are group members, but they have more of administrative tasks, and they're not actually the ones monitoring these social networking sites. So just remember, kind of like the football, baseball, hockey example, we really have to be careful and not make any assumptions. It is possible for one person to belong to all three or none of these groups. Notice the given information, N of T. So the size of set T is 13, N of F is 16, N of L is 13, and so on. And then they talk about the intersections, and they give us additional information here. Let's go ahead and draw a nice big square with 3 overlapping circles. So if you have 3 sets, you want your picture to be more of a square shape rather than the traditional rectangle. Just makes it a little easier to fit things in. So here I've got 1, 2, 3 overlapping circles. I want to go ahead and label these. This is T for Twitter, F for Facebook, and L for LinkedIn. Now, what I highly recommend and what I always suggest to folks, do not start with the individual sets. That makes it nearly impossible to figure out. Because when you see N of T is 13, that just means everything in T adds up to 13. But it does not tell us how that 13 is broken apart in the 4 different subregions. So what we want to do is start with this most specific information. Notice N of T intersect F intersect L. When you see all of those symbols, you should be thinking Twitter and Facebook and LinkedIn. There's 5 individuals. So that's right smack dab in the center of our diagram. At the same time, T prime intersect F prime intersect L prime, not Twitter and not Facebook and not LinkedIn. So basically the outskirts here contains 3 individuals. And then you just work your way up from there. So we've got both of those pieces of information in our picture. I'm going to move over to this middle column and look at these intersections. T and L, Twitter and LinkedIn. So Twitter and LinkedIn is right here on our picture. There needs to be a total of 6 individuals. We've already got 5, so we just need to put in 1 more. Next, let's move up one more spot, F and L. So Facebook and LinkedIn. That's going to be right here, Facebook and LinkedIn. There's a total of 10 individuals. We've already got 5 listed, so we need 5 more in our picture. That one's good. I move on to the next intersection, which is Twitter and Facebook, T and F. They tell us that T and F needs to add up to 9. We've already got 5 listed. We need 4 more, and then we can cross that off. Hopefully everything so far so good. Let's get into the original column here, N of T. So total in the Twitter circle, there needs to be 13. Now if you look, we've already got a total of 10. So we just need 3 more individuals. Next, for N of F, Facebook needs to be 16. We've already got 14 listed, so we just need 2 more. And then finally for LinkedIn, that needs to add up to 13 as well. We've already got a total of 11, so we just need 2 more in the LinkedIn circle. Once you have every single individual region accounted for, you can now answer any question they throw at you. Here they're just asking us the one question: how many engineers are there total in Scott's group? So in this case, I'm just going to go through, add up all 8 of the individual regions. So in this case, 3, 4, 2, 1, 5, 5, 2, and 3. You add all that together, you're going to get a total of 25 team members. So hopefully you've seen with that series of examples and with those ideas how you can take complex information with these surveys and all the given cardinalities, and really by making a nice Venn diagram, it allows us to organize and categorize that information much more easily. So that's going to do it for section 1.4. I do have an additional handout for section 1.4, and there's an additional video. It's optional, but it does have a few more examples just in case anybody's feeling like they need a little bit more practice with this. So feel free to check that out, but you're not obligated to do it. Don't feel like you have to. If you feel good to go on this, go ahead and try the problems on My Math Lab, and you might be good to go already. But if you feel like you need a little more practice, there's another handout and another video for section 1.4, so make sure to check it out.